Alright, chapter 9 is dealing all about sequences and series, so basically a set of numbers with a pattern, or it's something that we can associate with the previous number. So like with this, if you notice, this is Fibonacci sequence. This is a very famous, you can see it in patterns of flowers and butterflies and spiders and all sorts of madness, right? Spiders have 8 legs? Yeah, 8-legged spiders. So basically, you have 1, 1, 2, blah, 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 blah. There's a pattern. Basically, all that's happening in this one is you're taking the previous two numbers and adding it to get the next one. So 1 and 1 makes 2, 2 and 1 makes 3, 2 and 3 makes 5, right? Magic patterns. So all this is sequence in a series. We're not going to do one quite like this, although it is magical. But our terms, our first term is considered a sub 1. Our second term is considered a sub 2. A sub 3 is our first. A sub 4 is our fourth. And so on forever and ever and ever. So that we have a sub n, which is a sub any number. We can go up to 20, we can go up to 50, you can go up to infinity. Doesn't really matter how far we go. But a sub n can just be any number. That's all I'm trying to get the point across, is n is any number. Magic! Also, with a sub n, you will be given the sum rule, a sub n equals blah, 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 and blah, 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 where all you have to do to find the nth term is plug in whatever term for n. So if you want to find a sub 10, you have blah, 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 n is 10, wherever it is, blah, blah, blah. Okay, simple as that. So one type of problem that you will see is you will see something that says write the first 4 or first however many terms. So to find the first term, we're going to use this rule, a sub n equals 3n plus 4. If I want to find a sub 1, I'm just going to put 1n for n. So 3 times 1 plus 4. Well, 3 times 1 is 3, plus 4 is 7, so a sub 1 is 7. There's your first term. To find your second term, a sub 2, plug in 2 for n. So 3 times 2 plus 4. 3 times 2 is 6, plus 4 is 10. So we have 7 is our first, 10 is our second. To find your third, hey, you guessed it, plug in 3. And to find your fourth, plug in 4. So if you put in 3, 3 times 3 is 9, plus 4 is 13. Put in 4, 3 times 4 is 12, plus 4 is 16. Wait, notice all these have a difference of 3. We'll check that out. Your difference is the number right there. We'll talk about that more in 9.2 though. Okay, again, write the first 4 terms. So all I'm going to do is plug in the first ones. So if we do a sub 1 for our rule, then we have negative 1 to the 1 plus 1 all over 1 plus 2. So negative 1 to the second is positive 1. So I have 1 on top over 1 plus 2 is 3. Cool, that's 1/3. Go on to a sub 2. So if I have negative 1 to the 2 plus 1 all over 2 plus 2. Negative 1 to the third is negative 1. So we have negative 1. 2 plus 2 is 4, so we have negative 1/4. I bet you a sub 3 is going to be 1 over 5, and a sub 4 is going to be negative 1 over 6. You can check me if you don't believe me. I do lie sometimes, even though I'm standing up, but you can't see me, so you don't know. But I might be laying down. Ha! Another concept that I'm going to cover is the concept of factorials. You'll see n, exclamation mark. This doesn't mean to just go n as loud as you can and keep going about your math problems. N! Yeah, Carter's got it. So what this means to do is multiply all the numbers up to that number that is in the factorial. So for example, if we have 8, then we're going to do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Or if we had 9, we'd do 9 times 8 times 7 times 6 times 5 times 4, all the way down. So working with factorials, if we have something like 8 factorial divided by 3 factorial, I know 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 3 factorial is just 3 times 2 times 1. Well, to simplify this, I know 3 times 2 times 1 divided by 3 times 2 times 1 is 1. So really all this is 8 times 7 times 6 times 5 times 4, which is a lucky calculator number, and it is magical, and it likes bananas, and it is also 6,720. That would be it. However, ones like this are a little bit abstract, because we don't have a number, we just have something after. So like if this was 8 factorial, what this is, this n plus 1 tells us that we would actually want to go to 9 factorial. So this n plus 1, we have 1 times 2 times 3 times 4 times blah, 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 all multiplying together, all the way up to like n minus 1, the number before it, the number, and the number after. So I'm multiplying everything together all the way up to this n plus 1 term. Well, on the bottom, I'm multiplying everything together all the way up to this n minus 1 term. So I'm still multiplying 1 times 2 times 3 times 4 times everything up to the n minus 1 term. But that's as far as I go on the bottom. So in order to simplify this, all this jump divided by all this jump is 1. So the only thing that I'm left with is n times n plus 1. So n times n plus 1. This is also n squared plus n, but if you get this far, I'll be cool with that. Banana! Okay, I know that might have been a little bit confusing, so I'm going to do another one similar to it. Notice our top one goes all the way up to n minus 2, so we have everything, blah, 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 all the way up to the n minus 2 term. The bottom goes all the way to n plus 1, so on bottom we have everything starting from like n minus 2. We also have n minus 1. You have the nth term, you have n plus 1, and that's it, because we go all the way up to n plus 1. Now, n minus 2 and everything before it divided by the same thing is 1, so I'm left with 1 over all that jump. So I have 1 over n minus 1 times n plus 1. If you can get that far, I'll be cool with it. Happy day! Alright, last concept I'm going to talk about in this section. This is the summation notation. This big thing right here is sigma. Basically that just means take the sum from 2. So we start at n equals 2. We go to 4, so this is the finish, checkered flag, and we use this rule to add all the things together. So here's your rule, if I can spell rule. So let's look at an example. Alright, so this one is telling me to find the sum of 3i plus 4 from 3 to 5. So the first thing I'm going to find is my a sub 3, because that is where I start. I start at a sub 3. So if I put in 3 times 3 plus 4, this is 13. So that's 9 plus 4 is 13. So the first thing I'm going to add is 13 plus, I can find a sub 4. A sub 4 is 3 times 4 is 12, plus 4 is 16. A sub 5 will be 19. So I'm going to add 13, 16, and 19 all together. Let's see, 13 and 16 make 29, plus 19 is 48. That would be your sum of everything for 3i plus 4 from 3 to 5. All right, last example for this section. Again, we are finding the sum from 2 to 4. So I'm going to start at a sub 2, and I'm going to use this entire rule. So a sub 2, if I put into 1 over 2 squared plus 2, so 1 over 2 squared plus 2 is 1 over 6. Then I need to find a sub 3 because I need to go all the way up to 4. So 1 over 3 squared plus 2 is 1 over 11. And a sub 4 will be 1 over 4 squared, which is 16 plus 2 is 18. So now, using these fractions, I would say this is 1/6 plus 1/11 plus 1/18. And then don't worry about finding common denominators because that's going to take forever and it kind of stinks and smells like rotten cheese. So just plug it in your calculator and get a decimal answer. Whoa! Or just wait and hopefully it'll appear like magic. Hopefully this was helpful. I will see you guys in class. And as always, have a safe and wonderful night. And don't forget that the monkey loves you. The monkey will always love you.
Bye-bye.